Hello everyone, today the content I am going to explain is the structure and principle of yaw motors. Next, let's delve into the installation and troubleshooting of yaw motors together. First, let's take a look at the installation of yaw motors. The first step is selection and cleaning. After selecting the yaw motor, the installation surface of the yaw motor should be cleaned thoroughly with a cleaning agent and a large cloth. The second step is pre-installation. Insert the yaw motor into the motor installation hole from the upper side of the chassis and manually rotate the yaw bearing. Mesh the electric gear with the bearing gear. Insert the motor installation port completely into the chassis installation hole. Several yaw motors are effectively connected to the cleaned reducers. After the motor is installed, it is strictly prohibited to manually rotate the yaw bearing. The third step is to align the end faces. It is necessary to check whether the end face of the motor gear is aligned with that of the yaw bearing gear. If they are not aligned, the M2 locking screws on the pinion of the yaw motor need to be reinstalled. Then adjust the position of the gear end, face and lock it. The fourth step is to install the motor. Aligning the threaded holes of the motor and the chassis. Prefix them with 8 hex socket screws and slightly pre-tighten. The fifth step is to measure the gear clearance. Manually rotate the yaw bearing to mesh the bearing gear with the pinion of the yaw motor. Insert the feeler gauge into the back clearance of the meshing gear to ensure that a 0.5 mm feeler gauge can be inserted into the gear clearance, while a 0.75 mm feeler gauge cannot. The sixth step is to install the remaining motors. Install the remaining yaw motors in the same way as mentioned above. After installing each motor, it is strictly prohibited to manually rotate the yaw bearing. Any electromagnetic braking device is generally installed at the end of the shaft of the yaw motor. It is used to lock the motor when the yaw stops, thereby locking the yaw transmission. Next, let's take a look at the electromagnetic sand of the yaw motor. So how does it work? The electromagnetic brake coil acquires direct current through the non-phase windings of the motor. Power is supplied after rectification by the rectifier bridge. When the yaw motor operates, the electromagnet becomes electrified, attracting the moving armature to overcome the effect of the brake spring and separate from the brake disc. The brake disc is equipped with a friction layer which is fixed on the slotted shaft sleeve and connected to the motor shaft through a key to rotate together. Yaw shutdown causes the electromagnetic coil to lose power. The moving armature, driven by the brake spring, comes into contact with the friction layer of the brake disc and exerts pressure, thus achieving braking. The air gap adjustment process is shown in the figure. The air gap 11 is the gap between the electromagnet 5 and the moving armature 4. Its maximum value can reach 4 times the initial value. The air gap should be inspected regularly because the friction of the friction layer of the brake disc 2 will increase the gap. Loosen bolt 8 and adjust the brake regulator 3 to make the air gap reach the required value. Adjust the nut 10 to press the brake spring. Then separate the moving armature from the brake disc and let the shaft rotate. Pay attention to observe whether it is normal. Some problems may occur during the operation of yaw motors. If not dealt with in time, it will affect the overall operation. Then let's take a look at the fault analysis of the yaw motor. When the yaw motor reports a fault and stops working, one possibility is that it is a fault of the yaw motor itself. The corresponding solution is to use a multimeter to measure whether the resistance value and other parameters of the motor are reasonable. Remove the motor from the chassis and power it on separately. Observe whether it can operate normally. If it is indeed a motor failure, a new motor should be replaced or the motor should be repaired and then attached to the gauge. The second possibility is that the gauge has malfunctioned and got stuck inside, causing the motor to overcurrent. The corresponding solution measures are to remove the yaw motor and the input flange in sequence. Remove the first and second planetary gear assemblies. Take off the first and second internal gear rings. Remove the third planetary gear assembly cloth and take out the fourth center gear. Check if there is a large amount of iron filings in the base of the damaged part, and replace the entire gearbox or the damaged part. 3. It might be caused by the yaw output gear getting stuck with the bearing ring. The corresponding solution is to conduct on-site inspection of the cause of the jamming, determine whether there are any damaged parts, and replace the damaged parts. 4. It might be that the lubricating oil in the yaw gauge key has leaked into the motor. Trigger an alarm when the motor temperature rises. The corresponding solution is to remove the yaw motor and check if there is any lubricating oil entering. Drain the oil to the center line of the circular oil gauge. Replace the O-ring and apply flat sealant. Then install the treated motor. When there is an abnormal noise during yaw, it may be due to insufficient lubrication between the output gear of the yaw gearbox and the bearing ring, resulting in dry friction. The corresponding solutions are regular maintenance as required. Adding grease between the output gear and the bearing gear ring to prevent dry friction during gear meshing. The following table summarizes other common faults and their troubleshooting methods. For instance, the gauge key does not rotate after the motor is powered on. The causes include incorrect motor installation, the brake being in an alarm state, and internal faults. The corresponding solutions are respectively to check the motor installation, adjust the brake handle, and replace the motor with a new one. The above is the learning content of this class. Thank you all.